Let's start with question 6. Question 6 says the graph of f of x is equal to negative x plus 2. So negative x plus 2 is my straight line. So this line is y is equal to negative x plus 2. And then it says g of x is negative x squared minus 4x plus 12. So that's the parabola. So this is y is equal to negative x squared minus 4x plus 12. Okay, the graphs intersect by B and Q. So B and Q is the points of intersection, and B is also the x-intercept of G. Okay, but B is the x-intercept of both graphs. D is the turning point, so that's our turning point. F and E are the y-intercepts, okay? F and E, so there's E, there's F, they are the y-intercepts of the respective graphs. And here's our questions. 6.1 says, determine the length of AB. So determine the length of AB. So we have to work out what's the coordinates of A and what's the coordinates of B, and then work out the distance, eh? So A and B are my x-intercepts of my graph, okay? We can see it and it's given here, eh? So it's given, but we can also see it. So let's write down 6.1. For your x-intercepts of any graph, you let y be 0. So these are the x-intercepts of the parabola. Okay, because if I do that, I solve A and B. I write the equation of my parabola down and I make this y 0. Okay, and then I solve for x. So you can use the quadratic formula here. Your A will be negative 1 for your formula. Your B is negative 4. And your C is 12. And you substitute that in. I'm going to factorize, but I'm quickly going to change that negative. So this negative will become a positive. This negative will become a positive. So I'm just changing all the signs, eh? And this plus will become a minus. And I'm going to factorize. You can use the formula. So this is x and x. And I get 6 and 2. And I get the 6 to be a plus, and the 2 is a minus. So my x-intercepts are negative 6 or positive 2. So A is the negative number. So A is negative 6 and 0. And B is 2 and 0. So, okay, let's fill that in on our graph so we can just see. So I'm going to write A is negative 6 and B is 2. So now the length. So the length here is, so AB, you can use the distance formula, or you can just say my biggest x value minus my smallest x value. And that gives me 8. So AB is 8 units. So let's see, how did they mark this question? So for making the equation equal to 0, that is a mark. Then for factorizing or using the formula, that's a mark. Then for working out the x-intercepts, that's a mark. And for the length, that's a mark. And that's how you would get 4 marks according to the memo. Okay, our next question is 6.2. And it says, determine the length of FE. Okay, so another length of FE. Here's F, and there's E. Now, we said F and E are the y-intercepts of the graphs, eh? So let's start with E here on top. E is the y-intercept of the parabola. So I write my equation down of the parabola. I make, for my y-intercept, I let x be 0. So now y is equal to negative. Make the x 0 minus, that's squared, minus 4, 0 plus 12. I get my y to be 12. So my y-intercept is 0 and 12. So this E over there is 0 and 12. Okay, so let's work out F. F is the y-intercept of the straight line. So the straight line, I write the equation down. and I make x 0. So let x be 0. Y is equal to negative 0 plus 2. I get my y to be 2. So that y-intercept is 0 and 2. So I go here by f, that is 0 and 2. So now I have to work out the length of FE. Because it's just a vertical line like that, I just say the biggest y minus the smallest y. So the biggest y minus the smallest y gives me 10 units. And there you go. You can use the distance formula. There's the coordinates of E. There's the coordinates of F. So you can use the distance formula that you use in analytical geometry. But that is 10 units, So let's see, how did they give marks for this question? So they just gave 1 mark for working out E and F, and then for 10 units, and that's how you get 2 marks. Okay, 6.3 says, calculate the coordinates of the turning point D. So D is the turning point of the parabola. Do you see? There's D. So to get the turning point, for the x value of the turning point, we say x is equal to minus b over 2a. So when you look at the equation of the parabola, we're going to work out now. So we're going to say x is equal to minus, then this is b, the number in front of x. So that's b over 2. A is the number in front of x squared. So that's a negative 1. So you put that all on your calculator, and I get that answer to be negative 2. And then you take that negative 2 and you sub it into the equation. So you take that negative 2 and you make x negative 2. So negative 2 minus another negative 2 plus 12, and I get 16. So that means the turning point's x value is negative 2, negative 2, and the y value of the turning point is 16. And that's D. D is negative 2 and 16. So let's put that in here. So remember, as you work, you fill in a negative 2 and 16. As you work, you fill in on your diagram all the coordinates or equations that you are working out that you can put there. Okay, our next question is 6.4. 6.4 says, determine the range of G. So G is the parabola. So 6.4, if you have a smiley face parabola, the range is y is greater than or equal to the y value of the turning point. And if you have a sad face parabola, the range is y is less than or equal to the y value of the turning point. Okay, so we have a sad face parabola, and our turning point is negative 2 and 16. We need the y value. So therefore, our range is y, it's this one, is less than or equal to 16, because that is the y value of the turning point. 1 mark for that question. Next question, 6.5 says, determine the average gradient between point D and B. So average gradient is just gradient, So gradient on your formula page is this y minus the other y over x minus x. Okay, doesn't matter which one goes first, 1 or 2, it doesn't matter. So let's write our points down. It's point D and B. So D is negative 2 and 16. And B is this point over here. Do you remember we worked it out? It was 2 and 0. Can you see why you have to write that in? So it's easier to see. So now I'm just going to do y minus y. So I'm going to start with D. I'm going to say this minus that. So I'm going to say 16 minus 0. And then I start here again. So this minus that minus that. All in your calculator. And I get my answer to be negative 4. And that is the average gradient. Let's go. Let's mark this. So now here you get a mark, subbing it in, and the answer. So that's a 2-mark question. Our next question is 6.6, and it says determine the coordinates of Q. So Q is a point of intersection. So to work out a point of intersection, we make the two graphs equal to each other. So we're going to make the parabola equal to the straight line. So the parabola equal to the straight line, like that. And now we're just going to solve for x first. So I'm going to bring everything over to the side. So this is plus x minus 2 equals 0. Then I'm going to add the like terms. So negative x squared. This and this will give me negative 3x. And then this and that will give me a plus 10 equals 0. Okay, I'm changing all the signs. Since there's an equal sign, I can change it. So positive, positive, negative. And now you can use the formula or you can factorize. I'm going to factorize. So I get 5 and 2, a plus and a minus. I get my x to be negative 5 or x is a positive 2. So there's two x values, which means there's 2 points of intersection. We have 2 points of intersection. It's this one. It was B and Q. But they want the coordinates of Q. So can you see this point will have a negative x value. This one will have a positive. So we can see now that this B is 2. That B is 2 and there we got 2. So that means Q is negative 5. So I'm going to take this x value. Remember, a point of intersection has an x value and a y value. So to get the y value, I'm going to sub this point into either the parabola or the straight line. I'm going to use the straight line. It's easier. So there's the straight line. And then minus. And I'm going to put in this x value. So minus 5 plus 2. I get my y value to be 7. Okay, so therefore, Q has an x value of negative 5 and a y value of 7. And that's Q. So an x value there, negative 5, and a y value of 7. So now we can go to our graph and we can go make that point negative 5 and 7. Okay, this is for 4 marks. So let's see, how do they mark this question? For making the equations equal to each other, you get a mark. Factorizing or formula is always a mark. Then choosing the correct x value, so we choose negative 5 and subbed it in and got 7. So that's how you would get 4 marks. Our next question says 6.7. For which values of x is f of x greater than g of x? So let's write down 6.8. So where is f of x greater than g of x? So let's look. F of x is the straight line. So the question is, where is the straight line greater than, so let's say above, the parabola? That's the question. So for these questions, where one graph is above or below, we look at the points of intersection. So I'm going to do a number line. We have 2 points of intersection. We have Q and we have B. But the question said for which values of x. So that means I'm only going to write the x values of the points of intersection down. So this one, the smallest point of intersection, the lowest x value is negative 5. And then the bigger one is 2. Can you see I write it like that? Now I'm going to ask myself, where is it above or below? And I'm moving. So I'm going to highlight the first graph, whatever the first one is. F of x is the first one. F is the straight line. So I'm going to highlight that one. So look at this. I'm going to start from here to there. So let me first highlight the points of intersection for you. That's a point of intersection. That's a point of intersection. So from here to there, is the straight line above the parabola? It is above the parabola because there's the straight line and there's the parabola. So it's definitely above. So we write plus. Then from here to there, is the straight line above or below the parabola? Now there's the parabola, between those 2 points. So the straight line is below the parabola. So now here, I'm going to write below. And then, after 2, is the straight line above or below the parabola? Now, here's the parabola. There's the parabola. So this straight line here will be above. So it's above. Okay? So now I'm only going to look at above. Above means plus. Below is minus, eh? So let's circle. It's here and there. So as an inequality, you would write it like this. It's this side of -5 or it's that side of 2. So x is less than -5 or x is greater than 2. And then you ask yourself, was there an equal sign there in your question? Was it greater than or equal to or just greater than? In this case, it was just greater than. So that means here in our answer, we don't have these equal signs because the question didn't have equal signs. And that's the answer. And for this question, you get 2 marks. It's for the interval, so the right numbers, and the correct way of writing it. That's how you would get your 2 marks. 6.8 says, for which values of k will this expression have 2 equal roots? So you can use the graph or we can do it algebraically. So I'm going to show you. So for equal roots, let's write the question down. Now for equal roots, delta is equal to 0. For equal roots, delta is equal to 0. So b squared minus 4ac, that's delta, must be equal to 0. Now when you look at this equation that they gave us, our a is this number over here. So let's write down a is -1. B is -4. And C is anything without an x. So C is k. So I'm going to substitute that. So now b squared, so b is -4, minus 4, a is -1, C is k, equals 0. So okay, let's see. This is 16. This times this is a plus 4. And then times k. So 16 plus 4k is equal to 0. So I get 4k to be -16. So I get my k to be -4. So, and that's the answer. For which values of k will this have equal roots? Where k is equal to -4. And that is what your memo has, So, how do we get marks here? It's just a 2-mark question, So it's actually just inspection, but you can do it like that. This was a 2-mark question. So there you go. There you have your 2 marks. Just remember equal roots. Delta is equal to 0. And then solve for k. Okay, our last question here by question 6 is 6.9. 6.9 says, use the graph to solve the following inequality. Where is f of x times g of x less than or equal to 0? So this is 6.9. 6.9. Where is f of x times g of x, let's see, less than or equal to 0? Okay, so with this question, do you see there's a 0 in the question? So it means we're going to look at the x-intercepts of the graphs. So let's look at our x-intercepts. A was an x-intercept and B. So A is the x-intercept of the parabola. B is the x-intercept of the straight line and the parabola. So on a number line, the smallest x-intercept is -6. And the bigger one is 2. And there's no other x-intercept. So I'm going to ask myself, what happens before, between, and after? Plus, minus, plus, minus. But because there's a 0, it's not a point of intersection. We're looking at the x-intercepts. So our question is not where is the one graph above or below the other. The question is where is the graph above or below the x-axis. Okay? And we are going to look at both graphs, not just one. So we look at both graphs, not just one of the graphs. So I'm going to start with the parabola. Okay, let me wrap this out. So I'm going to do just extend my table. So I'm going to do this. So I'm going to do this. So I'm first going to do it for f of x. Then I'm going to do it for g of x. And then I'm going to multiply the answers. Okay, so let's start with f. I think f is the straight line. So I'm going to go on the straight line. So the point I'm looking at is the x-intercept. So what happens before and what happens after? So from here to the point of from here to the x-intercept, because that's the x-intercept just there. Is the straight line above the x-axis or below? So let's highlight the x-axis so you can see. This is the x-axis. Is the straight line above or below? It's above. So before 2, the straight line is above. So that's before 2, Then after 2, look at after 2. So from here to here, the straight line is below the x-axis. So below. So I'm going to do the same for the parabola. From here to the x-intercept, is it above or below the x-axis? It's below. Then from here to here, to the other x-intercept, is it above or below? It's above the red line. So let's change that. It's above the red line. And then after that parabola, here we go this way, it's below the x-axis, below. Okay, so now I'm just going to do a plus times a positive times a negative is a negative. A positive times a positive is a positive. And a negative times a negative is a positive. So now, because the original question, look there, our question had a less than, we are looking for the minuses, So let's look at our final answer. We only have a minus here. So in terms of a number line, you would write this side of negative 6. So the answer is, it is where x is less than negative 6. But now our question has an equal sign. So we also have an equal sign. And now because there's an equal sign, we also have to go look where else is one of our functions equal to 0. So where else is one of our functions equal to 0? It's here, there. The y value is the function. So the y value of b, so this is 2 and 0. There, our function is equal to 0. You see, y is equal to 0. So, or it's also where x is equal to 2. Because the question was, where are the two graphs less than or equal to 0? So here it's less than or equal, but here it's only equal. So remember, it's less or equal. So here it's less and it's equal. Here it's only equal. So we have to include the 2 as well, Question 7. So question 7 says, the graph of f of x is a to the x. So that's an exponential graph. And g of x is k over x plus p plus q. So that is the hyperbola. P is 1 1/3. So there we see p. And the points of intersection between f and g is q. Is f. P is 1 1/3. And this is the point of intersection between f and g. Q lies on f. So q is on the exponential. And it's also on the vertical asymptote of g, which is the hyperbola. Okay, let me highlight because they look the same. So this graph over here is the exponential. That's the exponential function. And then this one over here is the hyperbola. Okay, so that's the hyperbola and that's the hyperbola. And here's the asymptotes of the hyperbola. Okay, there's another point, 2 and 0. And then this is also an asymptote. Okay, so there we have it. So let's start with the questions. 7.1.1 says, determine the value of a. So there's a. So let's write that down, 7.1.1. So we write our function down. That's the exponential graph. So to get this a, we have to sub in a point on the exponential graph. Okay, so there's 2 points we can substitute. It's either you substitute q or p, because both of them are on the exponential. So I'm going to sub p. So my y is a third, a to the 1. Okay, so a to the 1 is a. A is the third. And that's how you can do that question. So that question was for 2 marks. Subbing in the point and getting the answer. That's 2 marks. Our next question is 7.1.2. Determine the equation of g. So g is the hyperbola. So let's write it down. 7, 1, 2. This is k, x plus p plus q. So to find the equation of hyperbola, you first have to fill in your asymptotes. So our vertical asymptote, so this line here, you see this point, it's where x is negative 2. So there is also the negative 2. So on this line, x is negative 2. So I'm going to first sub in k, x. If the asymptote is negative 2, then this is plus 2. Okay? Then do you see this asymptote, horizontal asymptote? On that line, there's a 0 and a 1. So that 0 and 1 is on that line. So that means on this line, the y value is always 1. So then this is plus 1. So there I filled in my asymptote. So that's the first thing you do. Then you sub in a point on the hyperbola. So we're going to sub in a point. So sub. Let's look. What point is on the hyperbola? This p is on the hyperbola. So I'm going to substitute. Oh, look here. The hyperbola also goes through the origin. So 0 and 0 is also on the hyperbola. So we can decide which one we want to sub. Let's do 1 and a third. So 1 and a third. So y is a third. K. And then x is 1 plus 2 plus 1. Okay, first thing you take over is the 1. So you're going to have a third minus 1. Okay. And then this is 3. Okay, so then we have a third minus 1 is negative 2 over 3. K over 3. And then we just cross multiply k. Take the 3 and multiply it with that. So 3 times negative 2 over 3. It gives me negative 2. So there I have k. So therefore the equation, so this is now negative 2. The equation is y is equal to negative 2. X plus 2 plus 1. Okay, so let's write our equations down. The hyperbola is negative 2. X plus 2 plus 1. And the exponential is y is equal to a third to the x. So there we have the equations. Okay, how do we mark this question? So for putting in the asymptotes, the 2 and the 1, that's a mark. For subbing in your point, that's a mark. For getting k to be negative 2, and then for giving the equation. That's how you would get 4 marks. Okay, our next question, 7.1.3. 7.1.3, they want the domain of G. So G is the hyperbola. So for the domain, we always write x is an element of a real number, but x cannot be this asymptote. So x cannot be the opposite of that. X cannot be negative 2. And that was for 1 mark. Okay, our next question, 7.2 says, write down the equation of k of x. Okay, k of x. K of x is obtained by reflecting f in the y-axis and translating it 2 units down. So, okay, I'm going to take f. Okay, there's f. Let's write f down. So, f of x is, remember we said this is the exponential. So, that's f. So, k of x is taking f and reflecting this in the y-axis. So, when you reflect in the y-axis, this x will change signs. So, it's a third now to the negative x. Okay, that's reflected in the y-axis. And now we must shift this 2 units down. So k of x is a third reflected in the y-axis minus 2. So there you go. That's 2 marks. 1 mark for doing that negative x and another mark for saying minus 2. And that's how you get 2 marks there. Our next question is 7.3. Determine the range of k. Okay, what was k of x again? It was a third to the negative x minus 2. So they want to know what's the range of this. So the range of this graph is, remember this graph is now just reflected in the y-axis. So the graph at the moment, the asymptote of the original graph was this line, y is equal to 0. But now it shifted 2 units down. So now the new asymptote is here. This line is called y is equal to negative 2 because it shifted 2 units down. So now the range is y is greater than the asymptote. So negative 2. And so that's the asymptote of the new graph of k of x. 7.4 says, determine the equation of the axis of symmetry of G in the form of y is equal to mx plus c. Okay, that's normal. If the gradient, so m, is less than 0. So this is the axis of symmetry with a negative gradient. Okay, this is for 3 marks, 7.4. So this is how you can do it. You say y is equal to y is equal to, because it's the negative axis of symmetry, you say minus, and then you put that there. So you take that whole thing and you just put it here, and you say plus 1. Okay, so remove the brackets. This is negative x, negative 2 plus 1. Y is equal to negative x, like terms, minus 1. And that's the answer. So if it was a positive gradient, you would just take it like this and that. So you would say positive. So now it's not in brackets because it's not a negative, plus 1. X plus 3. And that's the axis of symmetry with a positive gradient. But that wasn't the question. The question was the axis of symmetry with a negative gradient. Our next question is 7.5. 7.5 says, for x to be greater than or equal to negative 2, so that's a restriction. So this is a little restriction. Now this is the question. Determine the x values where f of x is greater than g of x. Okay, so let's do this part first. Where is f of x greater than g of x? So let's see. Where is f of x? Okay, where is f of x greater than g of x? Where is f of x greater or equal to g of x? So now, for these questions, we look at the points of intersection. Okay, there's no 0 involved. So let's look at the points of intersection. But because there's a hyperbola, because we are working with a hyperbola, we must also include the asymptote. So which asymptote? The vertical asymptote. So the vertical asymptote must also be included. So let's look at the points of intersection. So how many points of intersections do we have between f of x and g of x? So there's only one point of intersection. It's this one over here. It's P. So P is 1, the x value. We only look at the x value. It's 1. Then let's look at the asymptote. The asymptote is negative 2. So we are going to look at what happens before the asymptote, what happens between the asymptote and the point of intersection, and what happens after. Okay? We are highlighting the first graph. So we are highlighting f of x. Okay? We are highlighting f of x. Okay? So let me just highlight. Let me just do this. There is the asymptote, and there's the point of intersection. Okay, I'm highlighting the exponential function. Okay, so the exponential function is here. So the exponential function, remember an exponential function doesn't have a vertical asymptote. So an exponential function will go on forever and ever and ever, and it just never comes close to this line. The exponential function is something like that. Okay, so now before the asymptote, let's move on the exponential here. So before the asymptote, the exponential function is above the parabola. Then after the asymptote, the exponential function, so it's above the hyperbola, above the hyperbola. Then after the asymptote, so just after the asymptote, up until the point of intersection, the exponential function is still above. So it's still above. And then after the point of intersection, there, let me use another color. After the point of intersection, the exponential is below the hyperbola. So there it is above. So it's above the hyperbola and then it's below the hyperbola. Okay, the question is, where is it above the hyperbola? So it is above the hyperbola. So it's above the hyperbola here and here, because that's the plus plus. So from 1 to this side, it's above. But now we had a restriction. It says here x must be greater than -2. So this part is now out. We can only use this part. You see, it stops there. So x is between -2 and 1. And now my question has an equal sign. So I must also have an equal sign. So equal, equal. But one of these two numbers is my asymptote. This is an asymptote. So there can't be an equal sign next to an asymptote. So take that one away. And that is my final answer. So for 7.6, it says, use the graph to solve the following inequality. So we have to solve that. Now, when you look at that, that question almost looks like our function. So do you see the hyperbola? They look similar. So I'm going to rewrite this so it looks like our hyperbola, so I can use the graph. So what I'm going to do is I'm going to bring this to the left-hand side. So I keep that sign. I take it over. So this becomes -2. So, and then +1. So this is now 0. So now this is now the question. This is the same as this. So the question is actually, where is, this was g of x. So the question is, where is g of x greater than or equal to 0? That is the question. So, okay, that is our new question. So we just change the way it looks. So this means, where is the hyperbola above the x-axis? You know, when you have a 0, when you have a 0 with these inequality questions, we look at the x-axis and we look at the x-intercepts of the graph. So let's go, and we have to include the asymptote. So here's our asymptote, this vertical asymptote, because it breaks the graph up, and the x-intercept. This x-intercept, we can see it goes through 0 and 0. So on my number line, I'm going to have the asymptote and the x-intercept. So, okay, let's go. On the hyperbola, I'm going to move from left to right. So from here to the asymptote, is the graph above the x-axis? Here's the x-axis. Is it above the x-axis or below? So it is above, so plus. Then after the asymptote, but just before, so after the asymptote, but just before the x-intercept. So here we go. From there to there, I stop. Is it above or below the purple line? It's below, so this is a minus. So this is a minus. And then after the x-intercept. So there. Is it above or below the x-axis? It's above. Okay, so the question had above. So I'm looking for the plus signs. So this is a plus and that is a plus. So it's this side of -2 and that side of 0. So I write my final answer as x. X is less than -2 or x is greater than 0. And my question had an equal sign. So I also have an equal sign. So let's put the equal sign. But because there is an asymptote, this is the asymptote. There can't be an equal sign with an asymptote. So I will go take that equal sign away. And that's how you answer that question. And this question was for 3 marks. So changing the question like that is a mark. And then this is a mark and that is a mark. Your notation must be perfect. And that is question 7.